Generics, they are quite daunting, but do not worry because I'm going to teach you all about them. Now, when you think of the word generic, what comes to mind? Well, generic is something that is general, not specific. So in the context of programming, we mean code that is written in a way that can work with different types, rather than being tied to a specific type. For example, you may have a function that is going to recursively go through all of the strings of an object and it is going to trim them. Now you're not going to restrict it solely to one object. You want to allow absolutely any object to come through. But the problem is you're now going to resort to any because, well, you do not know how to retain that type information. So for this, we have this doSomething function. Takes in an input, any, and returns any. But if we take a look at the internal workings of this function, we can see that it returns the input as it came in. So when we declare a variable like some value, which is 5 plus 5, we know that it is going to be of type number. And if we invoke this function and we pass in this number and then take a look at the result, as we can see, it is any, which makes sense. But we're certain that it is going to return a number. So in this case, well, you would use type assertions. You'd say, I know for certain that this is a number, so I'm going to say as number. But imagine a function that is quite complex, spanning over hundreds of lines, and you're not entirely sure what it may return. It may return the number or object as it came in, or it may be partial of that object, or who knows what modifications were made. So resorting to type assertions is unfeasible. So that's where generics come into play. So how can we use generics? Well, for that, we can come here right after specifying the name of the function, so the identifier of the function, and we can open up these angle brackets. And within here, we can pass in a parameter list. So this type parameter here, for example, t, acts as a placeholder for a type that will be specified when the generic code is used. So think of generics also like parameters of a function. Here we have a parameter for a value, something that exists in the runtime. But in this case, we're defining something that only exists in the compilation. So now that we have given it an identifier, similar to how we're doing here for an argument, we can replace this with t. And then we can replace this with t as well. So again, this is an identifier that you can use all throughout. You can use it here for the arguments, you can use it for the return type, or even you can use it as a type. So you can say const value, and then this is of type t is equal to input. This is completely valid, just as doing input as t. So remember, this generic here is just for the type information. It is the same as an argument, but instead of you using it as a value, you're just using it as a type. Again, just for that type information. In the end, none of this will exist because it will get compiled to JavaScript. Now, let's remove this type assertion, and if we take a look at the return type, same value is of type number. So how did it work exactly? How come you told us that a generic is an argument, just as this is an argument for the function? Well, that's because TypeScript can infer it. When we pass in some value number, it is simply going to take that type information and it is going to assign it to t, nothing more. But you can do it explicitly, just as you're doing here where you're explicitly passing a value to this function. So here you can say this will be a number. So this is for the consumer, you pass in types, and here you just pass in identifiers. Now if we were to type this to say a string, well, of course we're going to get an error because now there's a type mismatch. It says that this function should now take in a string and it is going to return a string, but we're passing a number. Now, why would you type it explicitly? Well, exactly for this. You can also ensure extra type safety at the consumer level. So you can say, I want to pass in a string, and if you maybe make the mistake and pass in something that doesn't correspond to a string, well, you're going to get a type error. Now, let's take a look at a better example. Let's create a function, getFirstElement, and takes in t, now an array. So this is an array of t, and then this will return t or undefined, because the first element might not exist, the array might be empty. So for this, you can say array at 0, or you can use the method @0, whichever you prefer. And then we can come here and say const first element is equal to get first element. And if we pass in an array of numbers, for example, as we can see, the result is either number or undefined. So again, it is able to infer it automatically, just by the type information it can get from the value that we're passing in. Now we can do it here explicitly and we can say this will be a number. And again, this is going to resolve to an array of t, just as here this will be t without the array. You might be inclined to say this will accept an array of numbers, but now you're telling TypeScript that it is going to return an array of numbers or undefined or accept a two-dimensional array. So you need to be wary of this. Now we can also do const names, and then Alice, and then Bob, and then Charlie, and then we can say const first name is equal to get first element. And then you can pass in names, and well, this is going to be inferred as a string or undefined. And you can do whatever logic you want here. You can say array.sort and then add 0. So now let me show you a real world example. For this, we have this object. So as we can see, it contains numbers, it contains strings, it contains objects, it could potentially have even more objects nested, and it contains arrays. And well, each array might contain a number, a string, a boolean, whatever. And the idea is we want to create a generic function that is going to take in any object whatsoever, or even a string, and it is going to trim every single string, obviously ignoring numbers, objects, whatever. So for that, we can use generics, again, not to lose the type information. So we can say function trim strings takes in t, just one value, then values of type t, and it is going to return t. Why? Because it is the original object, just with the strings trimmed. And then switch type of value. So we take in all of the types. So this can be case string or an object or a boolean, whatever. So all of the supported types. So if you're not sure what the types are, we can say types, type of value. And if we do this, as we can see, it can be any of these. Now, in the case it is a string, it is quite straightforward. It is basically the base case of this function. We just trim the value. Now here's a problem, and if I remove this type assertion, as we can see, we get an error. Type string is not assignable to type t. And the problem is because by narrowing down the type with the case string, now value is a string. So when we try to return value, it does not correspond to t. Because t is a generic, it could be anything. So for that, we need to tell TypeScript, hey, we know that this is now a string, but we also know that it is t, because in the end, it is the exact same value, but trimmed. So we need to say as t. Now in the case it is an object, well, this could be an array. It could be, well, an object, or it could be null. So for that, we can say if value is equal to null, just return the value. We're not going to do anything with a null value. Then we have if array.isArray value, then we return value.map, and we simply pass in trim strings. Now you could say value and then trim strings value, and this is going to map over each one, recursively call this function, and it is going to apply all of this logic over and over again as many times as needed. But in this case, well, we can just pass in the function without invoking it, and well, internally it is going to pass in the value to this function. So this is a shorthand. And then again, we need to say as t, because the return value is t. And then we have finally the case for an object. So for that, we just iterate, we retrieve every key of value, and then we simply say value at key. So the object at that key, just trim the strings by passing in the value. As simple as that. And then we return value. And in the case that it is a boolean, undefined, whatever, we just return the value as it came in, because it can never be a string. So the huge benefit of using generics for this case is we can pass in this object, which we know contains all of these properties. And then here we get that same object. And so we get full type safety. So we get address, age, hobbies, name, everything intact, but these strings trimmed. So these are the basics of generics, and as you can see, they are incredibly powerful. Here we have just scratched off the surface. They can be way more complicated, and you can even restrict the type you pass in. So you can restrict this to only be an object, for example, but that will be for later on. For now, focus on building generic functions. Play around with it, see what works and what doesn't. And make sure to check out the TypeScript handbook. They have a whole page dedicated on generics, and they teach you all from the basics, like I did in this video, to using generic classes, to having generic constraints. So for example, if you only want to pass in an array in this case, and even generic parameter defaults, where you want to make a generic optional by providing a default value, similar to runtime arguments in a function. Anyway, this wraps up the video. I hope you enjoyed it and that you learned a lot. If you want to see more content like this, make sure to subscribe. I'll see you in the next one.